China has successfully landed its latest unmanned craft on the far side of the moon. The Chang'e-6 will collect samples using a robotic arm and also a drill to collect material from beneath the surface. Then it's to attempt a so far unprecedented feat, launching back from the side of the moon that always faces away from Earth. All right, exciting times. Francisco Diego is lecturer at the Department of Physics and Astronomy at the University College London. He joins us now from London. So happy to talk to you, sir. There have been a number of unsuccessful attempts made by other countries to land on the far side of the moon. How significant, in your assessment, is it that China's lunar lander managed to do it for a second time in a row?
It is very remarkable. I think China has a very robust space program, and especially when it comes to the moon, it has had extraordinary achievements. What we're witnessing now with the Chang'e-6 mission is a kind of replica of the Chang'e-5 a few years back that did exactly what this one is going to do now, to drill and to bring samples, although in that case was from the near side of the moon. And it was a very substantial, scientifically very important part of samples that brought back this kind of basalt, this kind of lava, solidified lava. That is the most recent lava that we have on the moon, about 2 billion years, which is quite recent in these terms. And it brought back a couple of kilos of that material. Now, in this case, it's going to be similar, but it's even scientifically even more important for a series of reasons. That the place where it's going to land has extraordinary perspectives for the future exploration of the moon.
Extraordinary. And what does this mean for China's space program?
Well, if this is successful, it's going to go ahead. It keeps going ahead with a very, as I said, very robust and very well-planned set of missions that are going to culminate in an international lunar station or permanent station on the moon.
Mm-hmm. And how long is this mission expected to last?
The mission we have now, the lander is now landed just a few hours ago, and we have very little information about. We saw only a time lapse of the landing in a very soft area, which is the Apollo basin within the Chang'e basin, which is the largest crater on the moon. It's a major, it's like a sea, which is what makes it this place extremely important. He will stay there drilling and collecting samples for a couple of days. He's going to drill 2 meters down, which is more or less what the Chang'e-5 did as well. Collect samples, which are pristine samples, on the largest impact crater on the moon, which is depleted several kilometers deep. This is a huge basin, more than 2,000 kilometers across, and it's going to dig material, which is unique. This material is the result of that impact that happened long time ago, and the material is completely different. Well, it's quite different from the materials that we have in the rest of the surface of the moon. So we want to analyze more about the titanium content, the iron content, even thorium, other kind of minerals that are apparently more abundant here. And this is what this mission is going to, if it's successful, in about 3 or 4 weeks' time, we will have the samples here back in the laboratories, and we will try to confirm all these numbers that we have on these abundances of this chemistry.
It's very thrilling what you're outlining there, and is that also the reason why there is such keen interest now in the lunar South Pole?
It is very important. Remember that this place, the Aitken Basin, the Shackleton crater, which is on the edge of that in the South Pole, and this basin is going to be the place where the human settlements will be in the future. So this is the very first steps towards that, analyzing the kind of composition of the terrain and the conditions there. It's an international collaboration as well with Sweden, Italy, France, and Pakistan as well. They were involved in this with different instruments, doing different analysis of the soil, the very thin atmosphere of the moon as well. And all these are data that want to be used by future missions to the moon by the whole all the space agencies all around the world.
Amazing. Francisco Diego, lecturer at the Department of Physics and Astronomy at University College London. Sir, thank you so much.
Make sure to subscribe to our channel to get the latest news from Al Jazeera.